Yo, what's up, guys? Welcome to day number 9, and today we're going to be starting off with some binary tree questions. The first binary tree question of our little series is going to be inversion of a binary tree. So, the question reads, you are given the root of a binary tree root. Invert the tree and return its root. So, for example, 1, 2, 3, 4, 5, 6, 7, and then the root becomes 1, 3, 6. So basically, everything on the right goes to the left, everything on the left goes to the right. So it's a little switcheroo. So how would we go about solving this? So from my understanding, with binary tree questions, there's always going to be like a lot of recursion involved. It's just the nature of it, and since it's a non-linear data structure, you have to treat traversal, because this is basically what it is. It's traversal, but it's reversed, so it's reversal traversal. Yeah, okay. But it's a non-linear data structure, so you have to treat it a bit differently, and it's not as simple. That's why we use recursion, because if you look at the diagram again, like, yeah, this is a whole tree, but then this is the subtree is also another tree, and another subtree is also another tree, and it's another, and it's another, and it's another tree. Like, you know, like it's like recursion is basically the best way to solve it. So as usual, we're gonna check if it's null, because if it's null, like, well, like, what are we reversing? If there's nothing to reverse, we need to return an empty thing. So if the root is equal to null, we are just going to say return null. So it's just going to be empty, simple as. Now we need to define the left and the right sides of the tree. So how do we do that? So obviously you see that there's a data structure here provided. So we just do tree node left is equal to tree node. You can't define it as an object, you need to call it as a function because we're solving this recursively. So it would be like invert tree root dot left. It's gonna be 1. Tree node right is going to be invert tree root dot right. Then okay, so cool. So we have set the right tree nodes com. Right, so what do we need to do now? So we need to swap since it's an inversion. So literally simple as you can do it, you do root left equals right, root dot right equals left, and then we return the root because that's what it wants. See how we do. Kangaroo. Alright, cool. So like this is right, see reverse. And this is why I do the base case testers, because we can get the algorithm completely right, but if we don't test the base case, we would have failed this test. And then like, okay, cool, this platform tells us what would the input, what the output, but say like you have 100 million test cases and then one fails, and you're like, but I've done the code right, why did it fail? And you're just like, trust me, for your future self, do it all the time, because I've learned the hard way. Alright, cool. I'll see for even 7 minutes, because if I'm talking all this and it doesn't submit, then wow. Right, I've successfully completed the problem. So day 9 is complete. Thank you guys for watching. Please like, subscribe, and I'll see you in the next one. See ya.